Good afternoon and welcome to the 8th flight test of Starship. What a gorgeous view there on your screen from Starbase, Texas. It is currently 5:05 p.m. Central Time here, and we are looking forward to tonight's launch of the world's most powerful rocket. I'm Kate Tice, Senior Quality Systems Engineering Manager here at SpaceX.
And I'm Dan Hewitt with SpaceX Communications. Welcome to our first ever broadcast from Starbase's new Star Factory building. I've been waiting a while to say that. Super excited. We are just a little over 39 minutes away and counting down to a liftoff at 5:45 p.m. Central Time today.
Yeah, and if you were wondering, yes, that is the pad just behind us. Now, just over 1 month ago, we saw the second ever tower catch of the Super Heavy booster there at that pad. And that was also the first ever flight of the next generation of ship, which successfully lit all 6 Raptor engines and flew for several minutes before contact was lost.
That's right. We completed our investigation following that mission, made a number of hardware operational changes for today's flight. We're going to detail all of those in just a few minutes. Important to remember, though, progress in a developmental program like this one, it's not always linear. There's no comparison, though, for putting that flight hardware in a flight environment to learn as fast as possible. And as always, primary payload for Starship flight test campaign is data.
The objectives for today's flight will look very similar to Flight 7. We're planning to deploy simulated Starlink satellites and fly a range of experiments. We've moved a number of tiles from ship. We've removed a number of tiles from the ship for reentry testing. We will also intentionally be stressing the flaps during reentry so we can test the limits of ship before we get ready to attempt future ship catches. So lots of new testing happening today, and as always, excitement is definitely guaranteed.
And just checking on things at the pad real quick as we're under 38 minutes away. We are tracking to 5:45 p.m. Central Time liftoff. We've got a window all the way to 6:30 p.m. We have started prop load. You'll start to see those frost lines building up on both Super Heavy and Starship. We're not tracking any technical issues, any range issues, any weather issues from a launch at that 5:45 p.m. mark. So we are loading prop on the vehicles, looking good for a launch in just a little over 37 minutes. Now, let's meet today's vehicle on the pad. It's the world's biggest rocket, Starship.
Yeah, you see it there on your screen, but to get an even better sense of how big Starship is, let's start with the average size human, which is about 2 meters high, or a little over 6 feet. Towering over our human is the length of the Millennium Falcon, which comes in at 35 meters. Our Falcon 9 rocket, which is has the payload fairing attached, is double the height of the Millennium Falcon at 70 meters. And twice nearly the size of that is the fully stacked Starship, just over 123 meters tall. The ship is about 52 meters tall, and the Super Heavy booster alone stands at about 71 meters. So it's pretty big. And we do have plans to make the ship and booster even taller in the future, if you can imagine.
And Starship itself features 2 major parts. We've got ship, that's the fully reusable upper stage powered by 6 Raptor engines. And then we have the Super Heavy booster, that's fully reusable first stage with 33 of those Raptor engines powering it. Super Heavy, the most powerful rocket ever flown. It's designed to launch, return, refuel, launch again with 0 refurb. And to make all of that happen, we also have Stage 0. That's everything else you see around it that enables Starship to fly. The tower, the orbital launch mount, quick disconnects, prop farm, everything. Stage 0 is also just as critical to achieving that rapid reuse as Starship itself.
Back on the rocket, the ship features 6 Raptors, 3 of them for sea-level engines and 3 for vacuum engines. Raptor Vacuum, or RVAC, is a similar design to the Raptor engine, but features a larger exhaust section and a larger expansion nozzle to maximize the engine's efficiency in space. It's also designed for vertical takeoff and landing on any hard surface, useful for when you're taking off from a place like Mars that's still waiting for its first launch tower.
And that ship is outfitted with 4 flaps that are used to control the vehicle's attitude during subsonic flight and to enable a precision landing. The 2 upper ones are right here. And then to achieve full reusability, the ship has to survive entry not just once, but multiple times, every single time we send it up and bring it back. It does that with its heat shield, which we iterate on every single flight as we're just building towards a heat shield that requires no refurbishment. The one today, it's still composed of those thousands of hexagonal ceramic tiles, and they're designed to insulate the vehicle during that atmospheric reentry where some of those temperatures spike up as high as about 2,600 degrees Fahrenheit. That's one of the real big things we're still working on. Rapidly reusable heat shield has never existed in history, so just continuously improving on it right now is just a key focus for all of these flight tests.
And then there in between the first and second stages is our hot stage. We saw that in action first starting on Flight 2. The hot staging maneuver is when the upper stage engines are ignited before the booster engines are completely cut off. With hot staging, the rocket never stops accelerating during separation. So it's actually more efficient than traditional stage separation, even though it sounds kind of crazy. You actually see it there on your screen now. That is one of the upgrades that we made on Flight 2, thanks to lessons that we learned on Flight 1. Several of the improvements and upgrades made for today's flight will unlock our ability to fly longer missions, something that we'll want to start doing, as we start doing orbital flights around Earth, and of course, eventually to Mars.
And Ship definitely had a lot of lessons learned on Flight 7, but Super Heavy Booster put on one hell of a show for our second ever return to launch site and catch. Marked our first reflight of hardware, shout out Engine 314, and it brought us a lot closer to full reuse. For more on that, get ready, Internet. We're going to be joined now by our buddy Chris out in Hawthorne. How's it going, Chris?
And thank you, Dan, and I couldn't agree more. Raptor 134 definitely started us down that path toward rapid reusability for the Raptor engines, and who knows, maybe we'll see it again. Stay tuned. Welcome everyone to Hawthorne, California. As you can hear, excitement is building as we count down to Starship's 8th flight test. Behind me, you can see one of our mission control rooms where engineers here in Hawthorne are assisting our flight control teams in Starbase, keeping an eye on various systems like Starship's avionics and, of course, those powerful Raptor engines that have quite a workout ahead of them today. Now, the Raptor engines you'll see and definitely hear today were manufactured right here in Hawthorne, California. And the engines on today's flight are all Raptor 2 engines, which is the same design we've been using for Starship's flight tests to date. And that includes all of the engines that have powered the 2 Super Heavy boosters back to Starbase for catch and recovery by Mechazilla. But here at SpaceX, we like to continuously improve our designs by eliminating the parts we don't need. We call this applying the algorithm, and that helps us simplify designs and drives us toward rapid, reliable reuse. And that's just what we're doing with our Raptor engines, like you can see here on your screen. I love this family photo of the Raptors because it really shows you the unprecedented step forward in rocket design that Raptor 3 is. And you can really tell that we applied the algorithm here, questioning the requirements for the engine, finding the parts we didn't need, and then optimizing for manufacturability and reuse. Now, one of the cool things about Raptor 3 is that it eliminates the large and heavy engine heat shields, which means that when we move from the Raptor 2 to the Raptor 3 engines on Starship, each Raptor 3 engine is going to save us about 1.1 metric tons of mass, and that's a lot of mass when you multiply that by 39 or more engines. So Raptor 3 will help us increase Starship's efficiency and as well as the amount of mass that Starship is able to deliver to space. And I gotta say personally, it's really exciting to be looking at the engine that will make life multiplanetary, beginning with Mars. But before we get to Mars, we still have a lot of important and critical development work to do. And it's flight tests like today's that help us do just that. So as we get ready for Flight 8, let's take a look back at last month's Flight 7.
Flight directors, go for launch. T-minus 5, 4, 3, 2, 1. We have one time. Vehicles pitching downrange. Max Q. Booster engine cutoff. Stage separation. Goose path burn startup. looks like we have lost a ship.
Oh man, seeing that recap, my hands got sweaty again in excitement watching that and in anticipation knowing that we're going to hopefully get to experience booster catch again. I know seeing my first booster catch, I'll never forget.
There's nothing like it.
Yeah.
Nothing on the planet.
Now, using the data from Flight 7, we've made some key improvements under the hood for today. Flight 7 taught us a couple of important things that changed some of our pre-flight testing to help us investigate more. First, we saw a harmonic response several times stronger in flight than we saw in testing.
And harmonic response, in this case, it's essentially vibrations that we're seeing go through the structure. Rocket engines, as you can imagine, create an incredible amount of noise and vibration, which then passes through every component of that rocket. And on Flight 7, we saw those vibrations happening at a very specific frequency, and they were placing some extra stress on that hardware in Starship's propulsion system. This is most likely what led to propellant leaks that we saw that eventually cascaded into fires and ultimately ended with loss of contact with the ship.
As part of our investigation, our team at Starbase took this flight's ship through a 60-second static fire on the Starship test stand, which is 10 times longer than any previous static fire. During this test, we cycled through multiple throttle levels. In fact, you can see that on your screen now. We cycled through multiple throttle levels on the engines to recreate different conditions seen within the propulsion system during flight. And we tested some hardware changes on fuel feed lines to the Raptor vacuum engines.
This gave us just the extra data that we needed to eventually implement new hardware that's installed in those fuel feed lines for the RVAC, the Raptor vacuum engines. Also tweaked a couple of other things like the temperature of the propellant as we're feeding it to the engines. Also the throttle level that we set for those engines during ascent. Having the ability to do a 60-second static fire, just one of the ways we're trying to expand our test capabilities here at Starbase. You want to test like you fly as much as possible. That just helps us to iterate even faster.
Yeah, exactly. The fuel feed lines to the Raptor vacuum engines, which are unique to this upgraded version of ship, look like large straws running through the oxygen tank. Today's vehicle has one of the hardware configurations we tested in that extended static fire because it showed it was able to minimize the harmonic response and lower its amplitude or strength.
We also took another look at where those fires broke out, specifically in what we call the attic. That's an unpressurized space between just the bottom of the ship's liquid oxygen tank and the top of those engine heat shields. Fires in that space resulted in a loss of vehicle back on Flight 2 and also on Flight 7. So we took some steps to make it more resilient to leaks in the future. To do that, we added a pretty hefty purge system. It's going to use gaseous nitrogen. It's pretty similar to the CO2, the carbon dioxide system we use on booster. It essentially just floods the zone with an inert gas to prevent a fire from ever starting. And then in addition to this, we increased the attic's natural fire defense just by adding some additional vent holes. That helps to keep the attic pressure as close to just vacuum as humanly possible as Starship flies into space.
And for the next generation of ship, we're running the algorithm. We're going to try and do the next best possible thing and delete some of the unnecessary space. So that ship will be using Raptor 3 engines, which will let us reduce the attic volume and eliminate the majority of joints that can leak into the space. In the end, what you're seeing take place with these changes is the core of our test program. We fly hardware all together in a real-world environment. We learn from the data, we make upgrades, and then we fly again. Ultimately, we fly to learn, and we're learning a lot.
That's right. Now, for today's flight test, we're going to be attempting to do everything we didn't get to do on Flight 7. We're still looking to get our first re-entry with this upgraded version of ship. Also intentionally trying to stress it to gather real-world data on just where the vehicle's boundaries are. So don't be surprised if it's not a smooth flight down to a landing for ship today. As always, it's going to start with liftoff. The 33 Raptor engines on super heavy igniting, lifting both it and Starship into its ascent, and it's going to power us all the way until hot staging.
Yeah, those engines on the ship will ignite while the ship is still attached to the booster. This will create that stage separation that we see there. Second stage will continue to go on its way. The booster will make a flip and come back here to the launch tower just behind Dan and I for hopefully what we will see the third ever booster catch.
Meanwhile, ship continues its ascent, gets into its suborbital place in space. We're going to have a test satellite deploy, pew pew, Starlink's firing out. And then we're also going to do a Raptor relight,
Countdown
relighting one of those sea-level
FPS
engines
one is
before we
calling a
get to
hold
ship
of a
re-entry.
troubleshoot by the state machine. Did
And
not
the ship will
successfully
continue through,
transition
make
during
its entry
startup
phase
problem.
that lasts for a few minutes.
And if some comms did just go out, we heard that an operator hold got in, so they are troubleshooting one issue. As we continue to move through prop load, we'll get some more details on what caused the hold, and if we start to reset to a new T0. We are still loading prop on the vehicle, so essentially putting that hold in means that if we get through everything and we hit that T-minus 40-second mark, we'll hold there and wait to clear the issue if we haven't cleared it at some point in the next 20 minutes.
Yeah, for those that are unfamiliar, that T-minus 40-second period is an opportunity to troubleshoot, unlike our Falcon timeline. So we do have a little bit of leeway.
Yeah.
Continuing on with today's plan, that ship will be making a soft splashdown in the Indian Ocean, as we have seen before. We are launching at 5:45 p.m. Today. This evening launch will allow us to have daytime views of the ship as it makes its splashdown. So,
Yeah,
good news.
It's a lot on ship's plate, but we're still hyper-focused on finding all of those real-world limits of Starship. We want to be able to prepare to return ship to launch site and catch it. A lot of these recent upgrades are just made to enable that to actually happen.
Flight 7 premiered a huge block of upgrades to the upper stage to add more capability to Starship. And with Flight 8 today, we're hoping to get through a full flight. Starting us off, the forward flaps got a redesign. They shrunk in size and shifted toward the top of the vehicle and away from the heat shield. And that will significantly reduce their exposure to reentry heating. Also, by making Starship 2 meters taller, we added about 25% more propellant volume, along with propulsion upgrades such as vacuum jacketing of the feed lines, new fuel feed line system for Raptor vacuum engines, and an improved propulsion avionics module.
Yeah, ship got a little bit taller. That extra prop's going to allow us to fly those longer missions. We're not planning on stretching it a whole lot more beyond this in future ones, but then, you know, once we're flying the next version a lot, it'll be going. Just like the previous flight, a lot of tiles have been purposely removed. Again, we're trying to stress test all of the vulnerable areas, call this the missing tile test. Those tiles are removed in strategic locations all across the vehicle, including critical areas like those tanks and over the flap seals, as we use this flight to just really push those boundaries. In addition to that, we have some metallic tiles, again, that are being tested, including one on the right of this animation that has some active cooling built in.
The vehicle's avionics also underwent a complete redesign with things like 4 upgraded Starlink terminals, combining Starlink, global navigation, and RF communications. You can see that location there on your screen. And on the sides of the vehicle, non-structural versions of the ship's catch fittings are installed to test the thermal performance, along with a smoothed and tapered edge on one section of the tile line to address hotspots that we observed during Flight 6.
And once more, we're back at testing some radar sensors on those tower catch arms. We did that last flight. We're doing it again as we look for some additional ways to measure the distance between the arms and the vehicle. Catching the ship's going to be pretty different from catching the booster. It does that flip right before, so your antennas are going to rapidly reorient. And so just having any extra sensors on the ground side, you're adding extra layers of control while the ship and tower talk to each other for a catch.
In another first, Starship will deploy 4 Starlink simulators. They are similar in size to our next-generation Starlink satellites. With unparalleled payload capacity and full reusability, Starship will be able to deploy our more advanced V3 Starlink satellites, which will revolutionize global connectivity with Starlink all over again.
Each one of those Starlink V3 launches on a Starship is going to add about 60 terabits of capacity to the Starlink network. To give you some context, that's about 20 times the capacity of what we're adding with every V2 mini launch on a Falcon 9 right now. That's going to help us expand Starlink's network, expand its impact in the coming years as we expand that access to high-speed internet all around the world and eventually beyond. And the Starlink simulators that we're deploying today, they're going to be on the same suborbital trajectory as Starship. We expect them to demise as they enter in the atmosphere. And then Starship's trajectory itself looks very similar to our last several flights, splashdowns targeted in the Indian Ocean. And on top of all of that, we're also going to relight a single Raptor engine again while in space. We're just trying to get data on in-space Raptor burns. You're going to need those for deorbit burns when we're doing orbital missions, and eventually when we're doing missions way beyond Earth and we're on our way to Mars.
Yeah, so just like you said earlier, Dan, there's a lot on Starship's plate for today. But one of the hallmarks of these Starship flights are the incredible views that we get throughout the flight, courtesy of Starlink. Every day, we're working to expand the Starlink network both on Earth and in space. For how all this connects us to the big mission, let's head back to Chris.
Thanks, Kate. And as fans of Starship may know that Starlink enables us to bring you a lot of those unprecedented views, both from space and on Earth. Personally, I love all those epic views of the plasma wrapping around Starship during re-entry. So thank you to our Starlink teams who enable all of those amazing views and the information we get. Now, in addition to the dozens of cameras on Starship itself, as you see on your screen here, we also have mobile Starlink camera kits deployed in the middle of the Indian Ocean, as you're seeing from a previous flight. Starlink also allows us to connect our aerial cinematography units on the ground at Starbase and at other strategic camera spots around Texas and the world. And that's all part of how it comes together to help us tell the incredible story of Starship both on and off the planet. So thanks to Starlink, Starship is now capable of streaming more than 120 megabits per second of real-time high-definition video and telemetry through every phase of flight. This not only provides those incredible views of re-entry for all of us, but also the invaluable engineering data to help our engineers rapidly iterate across all systems of Starship. And all of that streaming data today will be put to good use with the more than 30 cameras that are on the vehicle for today's flight. Now, Starlink is the world's largest satellite constellation operating in low Earth orbit to deliver high-speed, low-latency broadband internet. This provides internet access to people around the world, many of whom have never had connectivity before. As of today, Starlink is serving more than 125 countries, territories, and other markets, and has more than 5 million active customers and counting. But to meet the growing global demand for high-speed internet, SpaceX recently expanded its factory at Bastrop, Texas, and introduced Starlink Mini as well as an upgraded version of the Starlink Standard kit. Here's our first ever look inside our brand new Bastrop facility.
There's like an interesting stat where like the odds of being struck by lightning in your lifetime are like about 1 in 15,000. And we make 15,000 dishes a day. If the odds of a defect happening are the same odds as being struck by lightning in your lifetime, it's almost guaranteed to happen one time in this factory a day. So you have to have like a very intense focus on quality.
Right now, we're in Bastrop, Texas at the Starlink manufacturing site, just about 20 miles east of downtown Austin. So the main function of this site is to produce our standard Starlink kits. Right now, we're producing 15,000 a day straight out of the factory. Raw plastic pellets come in, raw aluminum comes in, and we make those into the Starlink kits and then ship them right out to customers' homes.
When you manufacture the product that you design in-house, you're forced to live with the mistakes. What that means is that you're very motivated to quickly innovate and iterate such that you can rapidly improve the process. Our previous generation of the production line was maxed out in terms of capability, and the demand for Starlink has kept growing. So when we sat down to go design this factory and this version of our production line, we were really forcing ourselves to innovate. The future of this factory is growth. We're in the middle right now of constructing an expansion to our current factory. We're going to add over 1 million square feet of manufacturing space over the course of this year and allow us to continue to insource more of our manufacturing processes so we can continue to go from raw material to completed kit within the walls of this factory. I can't understate the hard work of all the employees at this factory who've made this a reality. Less than 2 years ago, this was an empty building with no employees. And over the last 20 months, we've built a factory from scratch. We've gone from producing 0 kits to over 70,000 a week. And we've gone from 0 employees to over 1,000.
And it is incredible to see all of the tech in that facility that will help millions of people around the world the way they want to use it and the way that they need to use that technology. Definitely a lot of good things to come from our Bastrop facility. And while we're talking about the infrastructure that enables us to do all of these amazing things, you've probably seen some changes recently around Starbase. Coming online this year is the second tower at Starbase, and this tower has redesigned chopsticks and is built to accommodate the next generation of Starship and Super Heavy. It will have a redesigned launch mount and flame diverter system built to be rapidly reusable and hardy enough to withstand hundreds of launches at a time. Now, over at the production site down the road, we're also building a new integration and refurbishment facility called Gigabay. And Gigabay, as the name implies, will allow us to process more Starships at the same time over our current Megabays. But Gigabay isn't just for Texas. If that weren't exciting enough, we're also further expanding Starship operations into Florida, bringing production and launch capabilities to the Space Coast. As Starship flight testing, development, and launch cadence continues to pick up pace at Starbase in Texas, over in Florida, we're building a Gigabay as well. Gigabay will stand 380 feet tall and will provide about 46.5 million cubic feet of interior processing space and about 815,000 square feet of workspace. Now, as environmental impact statements continue for potential Starship launches and flights from both Launch Complex 39A at Kennedy Space Center and Launch Complex 37 at Cape Canaveral Space Force Station, we plan to complete the Starship launch pad at Pad 39A this year. And pending the completion of environmental reviews, SpaceX intends to conduct the first Starship launch from Florida from Launch Pad 39A later this year. Now, we're also interested in enabling Starship launches from Slick 37. And as part of this process, SpaceX has been given a limited right of entry for Pad 37 to conduct further due diligence at the site in order to move forward with the environmental impact study that's being led by the Department of the Air Force. Ultimately, we will have production, integration, refurbishment, and launch facilities in both Florida and Texas, driving the needed flight rate for Starship to help make humanity a multiplanetary civilization. And Kate, I could talk about this stuff for literally hours on end, but we've got a Starship to launch today. So how are things looking 11 minutes before launch here?
Yeah, it's pretty cool that we're getting close to go time. Quick update on range and weather. For the range, the area around the pad has been well cleared. This includes the land, air, and sea space. So all is clear on the range front. That also applies to over in the Indian Ocean. The sea and airspace has been cleared as well for ships re-entry. Once again, we are making a soft splashdown in the Indian Ocean. So just the buoy cams are out there, and we'll get some great videos once again. Weather, we have a 35% chance of violating the weather the weather constraints for launch today. So it's not perfect, but it's not bad. Visibility also not so awesome. We can see the tower here. We're 2 miles away from the launch pad, but visibility around the greater area might be a little challenging.
Yeah. In terms of the vehicle itself, so right now you can see we're almost done loading prop on ship, almost done on booster. If you tuned in and heard earlier, we did hear talk about a flight controller hold going in. So just a reminder, all that means is we wouldn't be able to pass that T-minus 40-second mark. They're literally talking about it right now on the loops that they think they've got the problem figured out. It was an issue on the booster where we think we will be clear by about the T-minus 2-minute mark, and we will be able to move right through that T-minus 40, hopefully. So, prop load continuing. We're not holding or anything yet, and we're expecting that issue to clear before we get to that T-minus 40 mark. This morning, though, we did all of the usual checkouts, aligned the navigation systems, did all of our booster and ship tank purges, got them ready for prop load, chilled down the pad, which you can see all the cryo right now.
Chilling.
Things are pretty chilly out there. Prop load's been going. We just did a flap check out. We also do a wiggle check out on the chopstick arms as well. We are going to continue loading prop for about another 6 minutes. We're going to close ship at about 3 minutes, 20 seconds before launch. Booster just about 30 seconds later. So we've had at least one issue that we're still working in the background, expecting that to clear before we hit that kind of that hold gate at T-minus 40 seconds, and looking good.
Yeah. So bottom line, things are looking good for liftoff here in just under 9 minutes. We're now at, looks like 8 minutes and 49 seconds. So everything's looking green so far.
Yeah. Before we get any closer to liftoff, I need to shamelessly plug Starbase. I'm one of just a couple thousand people who work here. soon to be the newest city in Texas at Starbase, and we're the largest employer in the area. We're always hiring, so visit spacex.com/careers, see all the openings. It's where the future is being built, and it's a future we can all be pretty excited about. So yeah, come work here. Anyway, back to our regularly scheduled program. Let's launch a rocket.
All right, so we're coming up to 8 minutes until liftoff. As we mentioned before, flight controllers are already on console. They're located in our Ad Astra Launch Control Center, about 6 miles away from the pad. But they will soon be moving here with us to Star Factory. So a lot of excitement around that, certainly growing.
Yeah, and again, general status check. We're continuing to progress. We're under 8 minutes away. We're tracking an issue with booster. We're expecting that to clear. Still looking good for launch. Speaking of booster, let's talk about catching one.
Absolutely.
The tower's 2 giant robotic arms that lift and stack Starship on a Super Heavy for final integration ahead of flight. We also use those to catch. It means we don't have any landing legs in the booster. Makes the booster lighter. Means we can throw more payload into space.
Exactly. Following liftoff and after the 2 stages separate in flight, Super Heavy will return to the launch site, the same exact launch site that it lifted off from, reignite its engines to slow the vehicle down. Here we see playback from a previous booster catch. I believe that was our first booster catch. The vehicle will slow down, tower arms will come out and catch the booster.
And just like the last few times, literally thousands of different vehicle pad criteria have to be met before we bring a booster back and try to catch it. We need healthy systems on Super Heavy, on the launch tower, and we need that final manual command from the mission's flight director for the day. If that command isn't sent before we finish the boost back burn, or if any of those automated health checks kick us out, the booster defaults to a trajectory, takes it to a landing burn and a soft splashdown in the Gulf.
Yeah, we have said it multiple times before, but it still holds true today. We accept no compromises when it comes to ensuring the safety of the public and our team, and the return will only take place if the conditions are right, and there are many of them. So there's a chance that we may not get to catch the booster today.
Yeah, and one aspect of the return and the catch of that booster is the audible sonic boom in the area around the return location that happens as the booster's slowing down from supersonic speeds. It's similar to sonic booms that were heard during the return and landing of NASA's space shuttle for anyone that was in Florida for those.
Sonic booms like these are unique to vehicles returning from space and are one of the hallmarks of reusable systems like our Falcon 9 and Falcon Heavy vehicles. The general impact to those in the surrounding area of a sonic boom is basically a brief thunder-like noise. And I've heard sonic booms before, but I got to experience my first in-person Starship sonic boom on Flight 7, and I can confirm it's pretty fun to experience.
And as someone who has heard sonic booms many times in Florida, they are definitely a hallmark, and what a way to announce a returning space vehicle's return for reuse. Now, here in California, as you can imagine, the excitement is growing here. The crowd is growing. Kate mentioned our flight controllers in Ad Astra in Texas. Here in Hawthorne, we also have controllers on console in Mission Control, helping those teams in Texas monitor Starship's various systems, including the avionics and those 39 Raptor engines that were built right here in Hawthorne. Now, with 4 minutes, 30 seconds to go, Dan and Kate, how are we looking for a launch today?
So we are still looking good. We're just about fully topped out on propellant on both vehicles. The closeout's going to be coming up in about a minute on ship, and then about 30 seconds later on the booster. We are still hearing chatter in the background about the booster issue that we're tracking. We may still be able to pass the hold, but if we need to hold at T-minus 40 seconds, we have several minutes that we can hang out there and work to just kind of troubleshoot those final issues before we get the go. Once we're fully loaded on prop, which is coming up soon, we've got just shy of 11 million pounds of liquid oxygen, liquid methane on both of those stages. And then once we're done, we're going to see that we're going to hear the ground lines do what's called pushback. So all of that propellant gets pushed out of those lines back to the tanks, clearing the pad for launch.
Now, in the next few minutes, the guidance system will perform a final alignment. The automated flight safety system will be armed, and thrust vector control, or TVC, checkouts will be performed. As we said, if we do need to hold, it would come at that T-minus 40-second mark. That is the point in the countdown where we can pause to wait for final checkouts or pressurization, or if we need to continue to work through that issue. So once we pass through that T-minus 40-second mark, a number of things are going to happen quite quickly. The ground spin and ignition systems come up to flight pressure. The ship's going to go on to internal power. And after that, the quick disconnect, or QD, arm lockout is removed in preparation for retraction shortly after T0. And once we do pass that T-minus 40 seconds, we still have the ability to recycle the count under certain conditions back to that T-minus 40 seconds and hold there to assess what happened and if we can proceed again to T0. But that's only in certain situations.
All right, so we're just about 2.5 minutes away. We do have a couple of things, like if we hit T-minus 10 seconds and you see water start flowing out of the deflector, that is a reason for us to scrub for the day, is that's once it's turned on, it doesn't turn off. And then we'll have to refill the tanks on both the water farm and the prop farm. Our team's gotten really, really good at refilling stuff really quick, so we can reposition for about a 24-hour recycle if we need to.
Yeah.
But
speaking of
we're
things,
coming up.
things,
We're coming up just under 2 minutes away. Now hearing we might hold at that T-minus 40-second mark while they still talk through a couple of troubleshooting steps. But again, if we hold there, we can hold there for several minutes, even with all prop fully loaded on the vehicle, before we can release the hold and decide to move forward. All right, less than 1.5 minutes away. Again, keep your eye on the clock. Look for T-minus 40. We may hold there. It's not a rocket launch unless you're talking nonstop in the background until right before you lift off.
Once again, if we hold at T-minus 40 seconds, we have an opportunity to hold there for several minutes. This is unique to Starship. We don't have this ability on Falcon.
As we're about 15 seconds away, we did just here. We are going to hold at T-minus 40. So look for the clock to pause when we hit T-minus 40 as they finish troubleshooting. And then we'll let you know as soon as we start hearing more, and if that clock's when that clock's gonna start rolling. So holding at T-minus 40. So the team's talking in the background, still troubleshooting, and we can hang out here for a couple of minutes. All right, and it sounds like we cleared the issue on the booster. We're now holding for a late braking issue with ship, so they're talking through that right now.
Dan, you mentioned things that we've gotten really good at. It's incredible to think that we just stacked this vehicle earlier this morning, and we're already, through prop load. Prop load's pretty much complete and ready to go. It's a very slimmed down timeline. Yeah,
this by far will be our fastest. We stacked the thing for the first time ever with these vehicles less than 24 hours ago. We really want to get to a point where we can, fly rapidly, fly as quickly as possible, and so this is definitely a case to try and push that forward. No wet dress or anything like that with these vehicles.
Absolutely. And should this booster come back for a successful landing, you were talking about the rapid part of rapid reusability. This booster may fly on a future Starship flight if we're able to catch it and bring it back online. So for those of you that have just recently joined us, we have paused at T-minus 40 seconds just to assess and work through a problem that popped up in the countdown, and we are holding here as the teams troubleshoot it. We believe that we have put in a solution and we will be able to proceed. But we have some chatter on some nets indicating that we're just holding here for a few more seconds. This is a great opportunity for the teams. This is unique on Starship. We don't have this ability on Falcon to hold here, partially because there's just so much propellant that it takes longer as a whole for it to cool down with that amount of volume that we have compared to the Falcon vehicle. But this T-minus 40-second hold is pretty cool because basically everything that would have been a scrub is actually just an opportunity to hold here and work through it. Or I should say many things, not everything. Like I said, we're working through an issue now, but we can also pause here for final checkouts or completion of pressurization to get up to flight levels, that kind of thing. So it's a nice feature to allow the team to wait for final checkouts or assess final prop levels or engine health and that kind of stuff.
All right, and if you're just tuning in, we are still holding at this T-minus 40-second gate. We cleared an issue on the booster that we were working up until the hold, still working one on ship, and team still continuing to discuss in the background. We can still hold here for several more minutes. If we're not able to resolve the issue or find a workaround, then we would have to essentially scrub and stand down for the day. If that does happen, we can go as early as tomorrow, but that clearly depends on what work we might need to do to fix any issues. So just obviously stay tuned. But right now, we're a little over 5 minutes into this hold today. We've got a couple more minutes that we can hold at T-minus 40 before we have to kick out. Essentially, looking at a lot of those propellant temperatures on both vehicles, you want those to stay in pretty specific ranges for engine startup and things like that. That's what generally drives how long we can hold at T-minus 40. So still hanging out. As soon as we hear an update on the ship, we will let you know. Starting to sound like we might have a decision real soon. All right, you see the clock rolling. It is time to go for launch. So, 30 seconds to go. Oh. And we just heard a hold. So we kicked. Psych. No. So we did kick out back to the T-minus 40 hold. All right, so as we started counting back down, we did trip a few more holds automatically from the booster itself. So we are now going to hang out here again at T-minus 40. They've got a couple more troubleshooting steps that they can take. If we're able to get through that, we can start counting down again. If not, we could always offload and try again on either tomorrow or another day. But right now, we're not done for the day yet. Still holding at T-minus 40 seconds. And as soon as we hear some more or start seeing that clock move, you will know if we're going to go for our launch attempt today or if we just try it again another day. So keep listening in, and we'll have an update shortly.
Go.
All right, and we did just hear the call. We are going to offload for today. So we had a couple of holds trip as we started counting down from T-minus 40 again. And it's not something we can change with small config tweaks. So we are going to offload our prop and then try again another day. So we're able to fully tank the vehicle. We're unable to lift off today, but just because we don't go today doesn't mean we're not going to go tomorrow or one of the days coming up. So we are going to start offloading all of that propellant on the booster and the ship. As we talked a little bit earlier, we can go as soon as 24 hours later. We won't know that for sure until we dig into everything that kicked us out of our attempt today. So obviously just keep an eye on all of our updates. So we are expecting could be about 24 hours, but we will definitely let people know.
Yeah. So we want to thank everybody for tuning in. Unfortunately, we would have liked to lift off today, but the teams are doing the right thing and standing down while we troubleshoot, and we'll share more information as it becomes available, including when our next launch opportunity is. So be sure to keep an eye on our SpaceX account on X, and as I said, we'll share more information as it becomes available.
All right. Thanks all for joining us today. We'll see you at the next attempt.